All right, people. I believe everybody is doing great, nice, and absolutely fine. And welcome to Unacademy NEET English. Let me know in the chats if I'm audible and visible properly. If I am perfectly audible and visible. Everyone in the chats, everyone. Okay, let me know, guys. And before starting this session, I want everybody of you to like this particular session. Okay, this session is very important for all the NEET aspirants out there. Okay. So I want you guys to like this particular session. Make sure you mark the attendance, okay? Then only we are starting this session, okay? And we will be completing the entire chapter in 2 to 2.5 hours, okay? And every single point I'll be covering, every single type of problem I'll be showing over here, okay? And this chapter is very important. You know why? Because when it comes to the entire 11th and 12th physics, this is involved over there in all the chapters. That's the reason we say this basic mathematics is very important. Okay, you have the integration, differentiation, maxima, minima, you have the slope. Okay, so in a lot of questions over there in electrostatics which are based on the calculus, which are based on the slope, okay, all of those will be basically discussed over here. So I want you guys to hit the like button as soon as possible, okay, with the fire emojis. Okay, good evening, good evening, good evening. And we'll be completing the entire session in 2 to 2.5 hours. Make sure you hit the like button as soon as possible. Okay, great. So a lot of you guys were saying that, sir, you didn't teach us the 11th portion, you didn't teach us optics on YouTube. Okay, so now is the game. We have started the game once again. Okay. Every single point. And if you give us these 45 days, okay, if you give us these 2 months, definitely you will increase your marks. That's for sure. Okay. Okay. So by this particular series. So give your 100%. If you have that aim to crack the NEET in the upcoming time. So we say this is the time right now. Give your 100%. Let's see if you can crack it, if you will crack it or not. Let's see that tomorrow. But as of now, you have to give your 100% because that is very much important. Okay. If you give your 100% today, if not today, tomorrow in the upcoming NEET in 2025, you'll crack 100%. That's for sure. Okay. Provided you have to give your 100%. Okay. And make sure you hit the like button, everybody of you. So we are starting this particular session without wasting the further time. Okay. With the fire emojis, guys, I want everybody of you to basically send the fire emojis in the chat so that you can boost my energy level also. Okay. So let's get started. Okay, let's start this particular session over here. Let's start this particular session over here. Okay, great. I can see a lot of people are sending the chats out there. Very nice, very nice. So I am starting this particular chapter. Listen to me very carefully. Guys, as I told you, this chapter is very important and I will be starting from the basics. Okay, every single point I will be covering over here. Make sure you make the notes from now on onwards only. Okay, make the notes now. So basic mathematics will be targeting the integration, differentiation, trigonometry, okay, all the concepts which help you to solve the problems in the upcoming physics, in the entire physics. So let's first start with the trigonometry. Okay, let's first start with the trigonometry. Everybody of you, listen to me very carefully. Let's start with the trigonometry. Over here, the first concept that we need to define in this particular case is, we say angle. Let's first understand what this angle is all about. All the people over here, let's suppose I take a circle over here. This is the circle which is in front of me. Okay, this is the circle that I have made over here. Now we say this is the center of the circle, and this is what we call the radius. Let's suppose R. If I say, let's suppose you are at this point A right now. At this point A right now. This is the point where you are sitting. And you started moving from this point, and you reached over here. Let's suppose point B. Okay, let's suppose point B. Can I say that when you moved in this circle from point A to point B, when you moved in the circle from point A to point B, we say you have moved some angle, that's let's suppose that is theta. You have cut some angle, that's theta over here. So I say on moving on moving on moving from A to B, on moving from A to B, listen to me very carefully. Listen to me very carefully. We cut an angle theta. We cut an angle theta. It means that while we were moving in this circle from A point to B point, we have moved an angle theta, angular displacement theta. Okay? Yes, sir. Now, if somebody asks you, can you tell me how much is this angle? How to calculate this angle? The simple formula that I want you guys to remember over here is this one. This is what we call the arc. Okay? How much you have moved over here. This is what we call we say arc. And if you have to find this angle, we say, sir, this angle is simply, we say arc upon a radius, okay? Simply, if you are moving angularly, means you are cutting the angle, okay? Now, in this case, if you have to calculate that angle, what will you do? You'll see how much is the arc, how much is this length, how much is the length of this arc, divided by the radius. How much is this particular radius over here? We'll get this one. Now listen to me very carefully. My dear friends, can I say in this particular case, this angle is theta? Because I told you, sir, this angle is theta. And we say arc is, let's suppose arc only. And how much is the radius of this particular circle over here? That is, we say r. And we can say, sir, this arc I can write, we say r into theta. We got this arc as r into theta. I want you guys to keep this in your mind. Okay? Simply, as of now, I told you, sir, how to calculate the angle. We say you have to see how much is the arc divided by the radius. You will get the angle. As simple as that. Tell me in the chats if everything is crystalline clear. Tell me in the chats if everything is crystalline clear over here, because this is the basic thing. Okay? Now, my dear friends, let's come over here. I want all of you to tell me with the fire emojis, is everything crystalline clear? Everybody out there, guys, tell me in the chats, is this crystalline clear? Okay. Now listen to me very carefully. Let's suppose if we talk about the unit of angle, okay, how much angle you have, how much is angle over here? We say we calculate the angle in radians, okay? We calculate the angle in degrees in minute per second. We don't have to go over here, leave this one. Let's focus on these two because we have to deal with these two maximum time. Listen to me very carefully. Sir, unit of angle. What does unit of angle mean? Unit of angle means how much is the angle. We say 50 degrees the angle, 40 degrees the angle, 30 degrees the angle. Similarly, pi radians is the angle. Like you say, mass is equal 10 kg. Kg is what unit? Now listen to me very carefully. Let's suppose, let me tell you what this radian is all about. Listen to me very carefully. My dear friends, if I say I have got the circle over here, okay? Let's suppose, listen to me very carefully. I'll make you understand each and every single point. If I say you started moving from this point and you covered this entire circle, you started moving something like this and you covered the entire circle over here. So you completed one cycle. Listen to me very carefully. I'll just write on completing one cycle, we covered. Sir, we know that if we have moved from this point to this point, means we would have moved by an angle of 90 degrees. If we move from this point to this point in entire circle, one complete cycle, we say we have moved how much? We say we have moved in one complete cycle. We say we have moved 360 degrees. We have, on completing one cycle, we say 360 degrees. We say 360. One complete cycle. Either you say 360 degrees or you say, sir, 2 pi radians. 2 pi radians. Means from now onwards, if somebody say, sir, on completing this one cycle, if you are moving in one circle, how much angle you have covered? You'll say, sir, 360 degree. Or you say 2 pi radians. It is one and the same thing. It is one and the same thing over here. Now listen to me very carefully, my dear friends. I can clearly say in this particular case, sir, this 2 pi radians is equal to 360 degrees. Either you say 2 pi radians or you say 360 degrees, both are one and the same thing. And my dear friends, if I say you have moved from this point to this point, how much is this angle? This is 180 degrees. This is 180 degrees. Or you can also call it the pi radians is equal to 180 degrees. Pi radians is equal to 180 degrees. Is that clear? Tell me in the chats, everybody. Pi radians is equal to 180 degrees. Is that clear? Tell me in the chats, guys. All the people out there. Is it clear to each and everyone, guys? Let me know in the chats. Let me know in the chats. Okay? 2 pi radians, 360 degrees. Now listen to me very carefully. Very important that you will be doing in the questions. That is nothing but the first question that I'm asking you over here. If you have to see, either we can convert this angle in degrees or we can convert this angle in radians. One and the same thing. Okay? Now, if I say I have got the pi by 2 radians over here, I'm asking you, how many degrees are pi by 2 radians? Is this 30 degrees, 40 degrees, 50 degrees? This is what we need to calculate in this particular case. Okay. Now, my dear friends, first I'll tell you the normal method. Then we will go with the trick. See, what is the normal method? Normal method is we can simply say, sir, as pi radians is equal to 180 degrees. Okay. We know, sir, if you are cutting the angle of pi radians means you're moving the angle of 180 degrees. Can I say in this particular case, sir, 1 radian will be simply 180 divided by pi. 1 radian will be simply 180 divided by pi, that unitary method. And I can say, sir, if I talk about pi by 2 radians, you can say, sir, pi by 2 radians will be simply 180 divided by pi multiplied by pi divided by 2. Okay, and this will cancel. This will cancel by 90, so it will come out to be 90. So means, sir, pi by 2 radians is how many degrees? 90 degrees. Sir, this is a long method. This is a long method. We want something which can help us to solve this particular question in just one step. See, I'll tell you. See, in this particular case, how many radians do we have? We say, sir, here, shortcut. We say we have got pi divided by 2 radians. Okay. We say we have got pi divided by 2 radians. Okay. Now, my dear friends, listen to me very carefully. I want you guys to do one thing. What is that? Instead of this pi, I want you guys to write 180 degrees because we know pi is equal to 180. So instead of this pi, I'll write over here 180 degrees. So we say 180. And you have got this 2 over here. I want you guys to divide this 2 over here. So how much it is coming out to be? We say, sir, 180 divided by 2 is 90 degrees directly with one single trick. One step and see how many steps are over here. What is the trick? If you have pi by 2 over here, instead of pi, I want you guys to write 180 because we know pi is 180. Divided by, we say, sir, 2, that will come out to be 90. Let's see one more question. If I say you have to convert this pi by 4 radians into degrees, how will you do it? You say, sir, this pi by 4 radians is equal to, instead of this pi, what I'm trying to say is that you write 180 degrees divided by, and you have got 4 over here, so 180 divided by 4, it will come out to be 45 degrees. In just one line, in just one step. I hope you are liking this method. Now, let's talk about this one. Pi by 3. Let's talk about this one, pi by 3. Sir, when it comes to this pi divided by 3, we can write this as, instead of pi, we can write this is 180 divided by 3. 3 ones, 3, 6, 0. It will come out to be 60 degrees. It is 60 degrees. Just 1 second. Okay. Now, similarly, we can say over here 5 pi divided by 6. Sir, we can write, see, Pi by 6 you will write as it is. This is 5 divided by 6 multiplied by. What is this pi? Instead of pi, you write over here, this is 180 over here. Okay. Now, how much this will come out to be? This is 150 degrees. As simple as that. Similarly, you can calculate this 2 pi divided by 3. You can write 2 by 3 as it is. And instead of this pi, you can write 180 degrees. You can write 180. So how much it will be? We say, sir, it will be 120. 120. It is 120. Is this clear to each and everyone? Tell me in the chats, guys. Is this clear to each and everyone? And make sure you hit the like button because that's mandatory. Make sure you hit the like button because that's mandatory. I want everybody of you to hit the like button as soon as possible. Okay, I hope you are liking this method. Okay, just one single turn. Guys, this chapter is very important. In order to solve the questions in bigger, heavy chapters, you have to be strong at basic mathematics. Okay, okay. Make the like count to 400, guys. Okay, great. Cool. Now listen to me very carefully. Now, if somebody says that, sir, convert this 30 degree into pi radians. Okay, sorry, into radians. Convert angle from degree to radians. Now see, how will we exactly do? What is the normal method? First, we'll go with the normal method. Sir, we say this is 180 degree is equal to pi radians. Okay. And if we say, sir, 1 degree is equal to pi divided by 180 radians over here. And similarly, if we say, sir, 30 degree is equal to, we can say pi divided by 180 multiplied by 30. Okay. And in this particular case, this will be, sir, pi divided by 6 radians over here. This will be pi divided by 6. Long method, 2-3 steps. But I want you guys to basically remember the shortcut. Shortcut over here also. What is the shortcut? Listen to me very carefully. We say when it comes to we say 30 degrees. If you have got the 30 degrees over here, can I just write it something like this, sir? 30 degree multiplied by 1 degree, one and the same thing, sir. Now we can say instead of this 1 degree, can I write pi divided by 180, one and the same thing. So you multiply it, pi divided by, we say, sir, 180 degrees. Okay. Now, in this particular case, it will be simply that is pi divided by 6 radians, just in one line. Whatever the angle you have, if you have to convert the degrees into radians, you multiply that with pi divided by 180. You multiply that with pi divided by 180, you'll get the answer in that case. Now, let's talk about the 60 degree angle. In case of 60 degree, can you tell me what is the value of 60 degree in radians? You say, sir, we can write it something like this. This is 60 multiplied by pi divided by 180. 60 multiplied by pi by 180. And this will come out to be, that is pi by 3 radians. As simple as that. Just one line answer. Sir, what about this 90 degree? We can say, sir, when it comes to the 90 degree, we can write it 90 into, we say, sir, pi by 180. And this is 91s, 92, so it will come out to be pi by 2 radians. As simple as that. Similarly, you can calculate for 120 degree. How much that will come out to be? We say, sir, this will come out to be, that is nothing but 2 pi divided by 3 radians. 2 pi divided by 3 radians. Yes, great. Now, let's talk about the trigonometric table. You might have studied this in your class 10th. Over here, we'll take a look. See, when it comes to the trigonometric table, I'll tell you what is the trick to remember this trigonometric table. See, first, we say, sir, sine theta, cos theta, tan theta. This is 0 degree, 30 degree, 45, 60, 90, 120, 135, 150, 180. You have to remember the values of all of these. How will you remember it? I'll tell you how to remember this. Now listen to me very carefully. Sir, when it comes to 0 degree, means sine 0 is, you have to remember, see. First, you will write this particular line over here. You have to remember this line. See, over here, if you have got this 0, sine 0 is 0, you will write 1 by 2. At 45, you will write 1 by root 2. At 60 degree, you will write root 3 by 2. At 90, you will write 1.
Now take a mirror, place a mirror over here. I have mentioned, place a mirror over here. Mirror will form, see, whatever, this is a trick basically. Whatever the objects you have over here, mirror will form its image, okay? So if you have got this root 3 by 3 over root 3 by 2 over here, similarly over here you have to copy it exactly. This 1 by root 2 you have to copy it over here. This 1 by 2 you have to copy it over here. This 0 you have to copy it over here. As simple as that. Now my dear friends, in the second row, what you are supposed to do? See. You have got this 1 over here. When it comes to the cos, take this 1 and place it over here. Okay. Then take this root 3 by 2, place it over here. And 1 by 2 will remain as it is. Then take this 1 by 2, place it over here. Take this 0, place it over here. This is the simple trick. And then once again, you have to copy all of these values, 1 by 2 over here, 1 by root 2 over here, root 3 by 2 over here, 1 over here. Just you have to put the negative sign. You have to put the negative. And this is for sine, this is for cos. And if I talk about for tan, we say, sir, over here you have to write 0, 1 by root 3, 1, root 3, and this will be undefined. Now, in this particular case, you have to remember it, and directly you can copy it. So this will be, see, root 3 is root 3, 1 is 1, 1 by root 3, and this is 0. Just you have to put the negative signs from this side. Is this crystal and clear to each and everyone? This was basically the trick to remember the trigonometric table. Since we are learning the basic mathematics, I told you I will not leave anything from basic mathematics. That's why I'm telling you each and every single point. Tell me in the chats, is this crystal and clear? I want everyone to tell me in the chats, is this crystal and clear? Everyone means everyone. Everyone means everyone. Everyone means everyone. I'm waiting for your chat, guys. Come on, all the people out there. Great. Just 2 to 2.5 hours. 2 to 2.5 hours. Maximum. The whole chapter will be completed. Okay? Great. Now listen to me very carefully, my dear friends. Trigonometric ratios. Sir, what does trigonometric ratios mean? What does trigonometric ratios mean? Listen to me very carefully. See. If we have got a triangle, let's suppose over here. I want you guys to keep your mind over here only. Okay. If you have got the triangle, let's suppose over here. Okay. And in case of this triangle, we define something. That is what we say, sir, sine of theta. Sine of this theta. 9th class I'm teaching you. We say, sir, this sine theta is simply this perpendicular, okay, this perpendicular divided by, we say some people have, we say, sir, hypotenuse. So we say sine theta is nothing but perpendicular upon hypotenuse. This is the hypotenuse, this is the base, and this is perpendicular. Similarly, if we talk about the cos theta in this particular case, cos of theta, we say, sir, that is base upon hypotenuse. Okay, some people have curly black here to present beauty. Tan of theta in this case, if we have to define, that is perpendicular divided by base. Perpendicular divided by base. As simple as that. See, these are what we call the trigonometric ratios. These are what we call the trigonometric functions, you say, ratios, you say, as simple as that. If you have to find the sine theta in this triangle, you say, sir, perpendicular upon hypotenuse. Similarly, cos theta, we say, sir, tan theta over here. Now, my dear friends, also, we say, sir, if we have to find in this particular case, that is nothing but, we say, sir, simply, that is cosec theta. Cosec theta, we can simply say, sir, hypotenuse upon perpendicular. The reciprocal of this one, hypotenuse upon perpendicular. Or you can also call it the 1 by sine. And if you have to define over here, that is sec theta, you can simply say, sir, sec will be hypotenuse upon base over here. Hypotenuse upon base over here in this particular case. Okay, opposite of this one. And then this one, you have got the tan over here, and we write over here, this is cot theta. And instead of cot, we can write, sir, base upon perpendicular. So these are the 6 trigonometric ratios that you have to remember, keep in your mind. We say sine theta is perpendicular hypotenuse. Its opposite is cosec theta, that is h upon p, hypotenuse upon perpendicular. Okay. Okay. Now listen to me very carefully, my dear people. Now there are some trigonometric identities, trigonometric formulas that you also have to remember over here. Sir, what is that? The first one is, that is the sine square theta plus cos square theta is equal to 1. Because in some questions, this will also help us to solve those questions. So that's why you have to remember this. Sine square theta plus cos square theta is 1. Okay. Another trigonometric formula is, that is cosec square theta minus cot square theta is equal to 1. And another trigonometric formula is, that is tan square theta minus sec square theta is equal to 1. All of these formulas you might have studied in your 9th class and you have to remember it. One more formula I want you guys to keep in your mind, that is nothing but, if you have got, let's suppose, sine of a plus b, sine of a plus b. Sir, we say, sir, if we have got sine of a plus b. Now, in that case, if somebody asks you what is the value of sine of a plus b, we say it is equal to sine a cos b. See. Sine of a plus b is sine a cos b. First you write sine a, then you write cos b. Then you say, sir, plus sine b cos a, or cos a sine b. If it is plus over here, it will be plus over here also. If it is minus over here, it will be minus over here also. Sine of a minus b is sine a cos b minus cos a sine b. Is that clear to each and everyone? Is that clear to each and everyone? Now, my dear friends, similarly, you have got the one more formula that you need to remember. Guys, make sure you make the notes, and these notes will be available in our Telegram channel. I want you guys to join that as soon as. See, we say in this particular case, cos of alpha plus beta, or you say a plus b. If you say, what is the value of cos of a plus b? We say, sir, it is cos alpha, cos beta, minus sin alpha, sin beta. Similarly, if I say, what is the value of cos of alpha minus beta? In that case, you say, sir, cos alpha, cos beta plus. If it is minus over here, you have got plus over here. Then sin alpha, sin beta. If it is plus over here, you have to put negative over here, minus over here. Is that clear? Now, similarly, if I say tan of a plus b, if somebody asks you what is the value of tan of a plus b, in that case, you say, sir, tan a tan b, 1 minus tan a tan b. This is the formula for this. All of these formulas you have to keep in your mind. All of these formulas you have to keep in your mind over here. Okay. Is that clear, my dear friends? Is that clear, my dear friends? Let me know in the chats. Let me know in the chats these formulas. Is that clear? And make sure you hit the like button, everybody of you. Tell me, guys. Okay. Tell me. Everybody out there, guys. Now, on the screen, you have got a question. On the screen, you have got a question from this trigonometry. Okay. Can you solve this particular question? The question is given as, if A is equal to B, okay? If A is equal to B, then you are supposed to find the value of cos A plus cos B. Guys, in this case, we know that when it comes to cos of, we say, sir, A plus B. What is the formula for cos of A plus B? Over here, cos of A plus B. Cos A cos B minus sin A sin B. Cos A cos B, we can write it simply, sir. This is nothing but cos A. We can write cos B minus, we say, sin A. We say, sir, sin B in this case. Now, it is saying that in the question, sir, A is equal to B. A is given equal to B. So can we say if A is equal to B is equal to, let's suppose it is equal to theta. Let's suppose it is equal to theta. Now put this over here. We say, sir, it is cos of theta plus theta, because A plus B, both are theta. It will be equal to, sir, this is nothing but cos of theta into, we say, cos of theta minus, we say, sir, sine of theta into, we say, sine of theta. So this will be cos of 2 theta is equal to, we can say, sir, cos square of theta minus, we say, sir, sine square of theta. Okay. Okay. Is that clear? Is that clear, guys? Now, I want you guys to exactly focus on few things over here. Guys, we have recently launched the Dream Crash Course batch for NEET 2024. In this crash course also, we'll be completing the syllabus in 45 days. Who are the teachers who will be teaching you in these batches? Wasim sir, me, Ambika ma'am, and we say HSP sir. We will be completing the entire syllabus in 45 days. So this is the dream crash course. Link is given in the chats as well as in the description. You can join it. The second thing I want you guys to basically over here is that I want to tell you is that if you want the notes, guys, listen to me very carefully. If you want the notes, like we say formula sheets, more specifically for physics, for chemistry, for biology, we have all of those formula sheets completely free. You don't have to pay. The link is in the description below. You have to join that link. You have to log in and you have to download the formula sheets for all the chapters. Okay, you can do it later on, not now, later on. And one more thing is Unacademy scholarship test is basically coming up. You can join this scholarship test, okay? And you can win, in this case, laptop, speaker, smartwatch. And this test will be on 17th, 11 a.m. and 5 p.m. Okay, you can basically go for this also. Okay, now my dear friends, let me just a second. Yes, find the value of we say sine of 75 degrees. Find the value of sine of 75 degrees. If let's suppose you get a question something like this. Okay, we say find the value of sine of 75 degrees. Listen to me very carefully. In order to solve this problem, can I write this something like this? Sir, sine of, we can write 75 degree. Can we break it something like this, sir? 45 degree plus 30 degree. Yes, sir. 45 plus 30. Now we can write it something like this. This is sine of. Instead of 45, we can say, sir, A plus B. It is exactly similar. In this case, A is 45 degree and B is 30 degree. It is one and the same thing. Now, do you know the formula for sine of A plus B? We say sine A cos B plus cos A sine B. Yes. Now, that is sine of A plus B is sine A, that is sine 45. Then we say cos B, we say cos of 30 degrees. Then we say, in this particular case, we say, sir, this would be over here minus, I'll write that is sine of, we can say 30 degrees, cos of 45 degrees. Okay, just put up the values of all of these. Just put up the value. Sine 45 is 1 by root 2 multiplied by cos 30 is root 3 by 2 minus we say 1 by 2 and then we say 1 upon root 2. Solve it and you'll get the answer. Follow it, you'll get the answer. As simple as that. In order to find the value of sine of 75 degrees, just break it something like this and you'll find the answer. Okay. Now, listen to me very, very, very carefully. Listen to me very, very, very carefully. This is the triangle which is very important triangle. Sir, why is this triangle important? Because this is the triangle which we use in maximum number of questions in physics. Okay. See, this is the triangle in which this angle is 37 degrees. From now onwards, my dear people, listen to me very carefully. You'll have to remember this. If you see a triangle, in which angle is 37 degrees, if you see a triangle in which angle is 37 degrees, we say this side in that case would be 3, this side in that case would be 4, and this side in that case would be 5. And there is one more triangle. There is one. Okay, put up the positive sign, plus sign over there. Not a problem, guys. See, now, if you see one more triangle over here, sir, in this case, this angle is 53 degrees. And whenever you see a triangle of 53 degrees, this angle, you will say simply, sir, this side will be 4, this will be 3, and this will be 5. See, what is the difference? You have got the smaller angle. In front of the smaller angle, you have the smaller side. In front of the bigger angle, you have got the bigger side. This would be smaller and this would be bigger over here. This remains same. Now, in this case, if I ask you to tell me over here, in this particular case, what is the value of sine theta? What is the value of cos theta? And what is the value of tan theta? We say, sir, when it comes to sine of 37 degrees in this case, because we have to find the value of sine theta, means sine 37. theta in this case is given as 30. So we say sine is equal to perpendicular upon hypotenuse. So what is perpendicular in this case? That is 3. Hypotenuse is, we say 5, 3 divided by 5. Then we say, sir, cos of 37 in this case would be how much? Black here, that is 4 by 5. And then we say, sir, tan of 37 degree in this case is perpendicular by base, that is 3 by 4. That is 3 by 4. Similarly, you can calculate in this one, sine, cos, and tan. Sine, cos, and tan. Okay. You have to remember this. You have to remember this. And you have to remember this directly in your mind. In front of the bigger angle, you have got the bigger side. Is that clear? Very important concept. Small angle approximation. Small angle approximation. This also we use in our concepts. Listen to me very carefully. When it comes to the small angle approximation, listen to me very carefully. Let's suppose we have got a triangle over here. Let's suppose we have got a triangle over here. Okay. This is the triangle that we have got. This is the triangle that we have got. And in this triangle, this angle is, let's suppose, theta. This angle is, let's suppose, theta. This is, we say, sir, perpendicular. This is, we say, sir, base. And this is, we say, hypotenuse. If I ask you to tell me over here, what is the value of sine theta? You'll say, sir, perpendicular upon hypotenuse. Now, I want you guys to decrease the angle. Now, if the angle is small, listen to me very carefully. I'll not be deriving it over here. I'll not write the proof over here, but I'll tell you to directly remember it. See, in this case, angle is having a good value, okay, 30 degree, 40 degree, whatever it may be. Now, if I want you guys to make the angle smaller, how can you make it? See, we'll make it something like this. We'll make it something like this. This would be the angle if you make it small, okay? In this particular case, this is hypotenuse and this is base and this is theta. And theta in this case is, we say, sir, small. Theta in this case theta is bigger. In this case, theta is small. If the theta becomes small, listen to me very carefully, guys. If the theta becomes small, we say in that case, we say the value of sine theta becomes equal to theta. Value of sine theta, we assume it equal to theta. There is a proof for this one. I'll not show you the proof over here, but I want you guys to remember it directly. Okay. Sine theta in that case becomes equal to theta. If the angle becomes, if you see from now onwards, okay, in electrostatic, that charge is attached to a thread. Over there, we assume that this angle is very small. Theta is very small. So we say in that case, sine theta is equal to theta. Sine theta is equal to theta. So my dear friends, from now onwards, see. If I say in this particular, this is perpendicular. If I say in this particular triangle, tell me the value of sine theta, I will directly say theta. Why? Because theta is very small. And we say, and listen to me very carefully. We say cos of theta is equal to 1. Cos of theta is equal to 1. Okay. There is also proof for this one. Sine theta is equal to, we say, theta. Cos theta is equal to 1. And my dear friends, we say tan theta. When it comes to tan theta, see, tan theta, we always say it is equal to sine upon cos. Sine upon cos. And what is the value of sine? That is theta. What is the value of cos? So it will be also theta. So from now onwards, you'll remember one thing. If theta is very small, in that case, sine theta is equal to tan theta. So sine theta is equal tan theta. Tell me in the chats, is this crystalline clear? This is for small. That's why we say small angle approximation. Is this crystalline clear to each and everyone? Tell me in the chats, guys, everybody of you. Everybody out there, guys, make sure you hit the like button. Everybody, I want all of you to make the like count 500 plus as soon as possible. Everyone means everyone. Everyone means everyone. Everyone means everyone. You can write it over here. Is that clear? Small angle approximation means from now onwards, if in any case theta becomes very small, over there you say, sir, sine theta is equal to tan theta is equal to theta, and cos theta is equal to 1. Okay, great, super clear. Any sort of doubt anywhere, please tell me in the chats. I need to know. If anybody is having any sort of doubt, I need to see. I'll not repeat, but I need to see. Who is the one who is having the doubt? I need to see. Okay. Now, let's move on to this particular question. If I ask you to tell me, guys, join this Telegram channel, Yawar Manzoor. That is t.me/Yawar Manzoor. Okay. You'll get the PDF notes over here. Okay. You'll get the PDF notes over. Now, see, my dear friends, we have to find the value of sine of 2 degrees in this. See, 2 degrees is a small angle. We say, sir, for a small angle, we say for a small angle, listen to me very carefully. For a small angle, if we just write over here, we say, sir, sine theta is equal to theta. We say, sir, the value for small angle sine theta is equal to theta. What is the value of theta in this case? Theta is 2 degree. So value of sine of 2 degree is 2 degree only. So we say in this case, sine of 2 degree is equal to 2 degree only. Okay. Now, if you have to calculate this in radians, 2 degree into radians, how do you calculate? Sir, we take this 2 degree and we multiply it. With, we say, pi divided by 180 degrees. That would be simply pi by 90 radians. So the value of sine of 2 degrees, how much? Pi by 90 radians. Okay. Now, similarly, what is the value of tan of 3 degree? Sir, we say for small angle, we recently saw that for small angle, we say, sir, tan of theta is equal to, we say, theta. So we say tan of 3 degree is equal to 3 degree itself. So that is 3 degree itself. And if we have to find this in radians, this would be 3 degree. If we have to find this in radians, multiply it pi divided by 180 degrees. Okay. So it would be, we say, sir, that is pi divided by 60. Is that clear? This is pi by 60 radian. Pi by 60 radian. Is that clear, guys? Okay. Next we have over here cos of 3 degree. Can you tell me what is the value of cos of 3 degree in the chats? Can you tell me what is the value of cos of 3 degree in the chats? Everybody out there. Sir, when it comes to the cos of 3 degree, we say it is equal to 1. Because I told you, for small angle, cos of theta is equal to 1. Sin theta is equal to theta. And if I say, sir, cos of 2 degree is equal to 1, cos of 0 degree is also 1, cos of, sir, 1 degree is also, we say, 1. Yes, great. Now, trigonometric function change. Listen to me very carefully. When it comes to trigonometric function change, let's suppose I make a graph something like this. Is important. I make a graph something like this. I'll draw a line over here. I'll draw one more line over here. Guys, listen to me very carefully. We say, sir, this is, if you draw an angle over here, this is 0 degrees. On this line, we mark an angle of 0 degrees only. Now, if you move from this line to this line, so you are moving at an angle, by an angle of how much? We say, sir, 90 degrees. Because this is 0 degree and between this and this angle is 90 degrees. So moving from this to this, it is 90 degrees. So we say this is 0 degree line, this is 90 degree line. Or you say this is pi by 2. Pi by 2 is also 9. Once again, if you move from this point to this line, so you have moved from, this is 180 degrees. So this is 180 degrees. How many degrees you have cut over here? 180 degrees. And once again, if you move from this line to this line, you are moving by an angle of 270 degrees. 0 degree, 90 degree, 180 degree, 270 degree, and 360 degree. Total. One cycle, 360 degree. Guys, listen to me very carefully. We say, this is what we call the first quadrant. This one is what we call first quadrant. This is what we call second quadrant. This one is what we call the second quadrant. And my dear friends, this is what we call third, and this is what we call the fourth quadrant. Listen to me very carefully. Listen to me very carefully. In this particular case, we say add sugar to coffee. Add sugar to coffee. You have to remember this. What does that mean? Means in this first quadrant, we say all are positive. Means all means one. Which one? We say, sir, all means sine, all means cos, tan, sine theta, cos theta, tan theta, whatever it may be. All the trigonometric ratios in the first quadrant are positive. Sir, how can you say it? Let me show you. Let me show you. Let me show you. Let's suppose we have got this one. This is the first quadrant, second quadrant, third and fourth. If I draw a line over here, this is perpendicular, this would be base. Tell me. From this side, we say, sir, it is plus x, it is minus x. This is plus y, and this is minus y. Tell me, guys, in this case, if I write sine theta over here, sine is perpendicular upon hypotenuse. Perpendicular is from the upper side, means it is positive. Hypotenuse is also positive. So positive is positive. So sine theta in first quadrant is positive. Similarly, if you find cos theta, base is also positive from this side. If I would have said from this side, base is negative. So cos theta positive, tan theta positive. But if you talk about the next quadrant, second quadrant, we say in second quadrant, sine is positive only, but cos is negative. Why? Cos is equal to base upon hypotenuse. Guys, hypotenuse in this case is positive, but base is negative. Base is negative because this is minus x. Base is negative. So that's why cos is negative, tan is negative. So directly you guys remember in this case, when it comes to the first quadrant, we say all are positive, sine, cos, tan. When it comes to the second quadrant, we say only sine is positive. Values of sine theta is positive in the second quadrant. And we say third quadrant, only tan is positive. Only tan is positive. And when it comes to the fourth quadrant, we say only cos is positive. All sine, tan, cos, rest are basically negative. Now, my dear friends, what I want you guys to remember in this case is we have to learn the function change. What does function change mean? Listen to me very carefully. I'll just write. We can change sine. I'll write over here. Function change means we can change sine into cos and vice versa, cos into sine. We can change tan into, we say, sir, cot, and vice versa over here. So function change simply means changing the sine function into cos function. Sir, example, I'll tell you. We say, sir, it is sine of 90 minus theta. We say it is sine of 90 minus theta. Sir, you have to change this sine function. This is what we call the sine function into cos. Change. Sir, you said you can change sine into cos. So we can write, instead of sine of 90 minus theta, we can write cos of theta. But you have to mention the sign over here also. You have to mention the sign over here also. Whether this sign should be positive or negative. Let me tell you how do you find that. Listen to me very carefully. 90 minus theta. 90 minus theta will be which one? 90 minus theta will be which one? Guys, this is 90 degrees. If you move 90 minus something, will be this quadrant, okay? 90 degree plus something. If I say 90 degree plus 20 degree, that is how much? 90, 100, 110 means it would be something like this in the second quadrant. If I say 90 minus theta would be first quadrant. And in first quadrant, we say sine is positive. See, guys, if you have to change any function, first of all, you can change sine into cos. You cannot write cot over here. You can change this sine into cos. You can change the sine into cos. You can write sine 90 minus theta is equal to cos theta, but you can write plus cos theta. Why? Because 90 minus theta is equal to first quadrant. This is what we call first quadrant. And in first quadrant, we say sine is positive. Because we are changing the sine function to cos. Now see, let me write cos 90 minus theta. Sir, cos function we can change into sine function. So it is sine theta. Now we have to see whether we should put positive over here or negative over here. It depends. See, 90 minus theta is first quadrant. And in first quadrant, we say cos is positive. So it would be plus. Hey guys, are you able to understand this? Tell me in the chats, everybody. Tell me. Is it getting crystal and clear? Similarly, if I say sine of 90 plus theta, similarly, if I say sine of 90 plus theta, we can write over here sine of 90 plus theta is simply, we say, sir, cos theta. Sine of 90 plus theta is, we say, sir, cos theta. Whatever the information I give you over here, we need that much only. Don't go over there. Don't go over here. Whatever the information, we need that only. Okay. So we say sine can be converted into cos. Now it is 90 plus theta. Sir, 90 plus theta is which quadrant? 90 plus theta is this quadrant. And in this quadrant, we say sine is positive. See, sine is positive. So it would be positive. Okay. Similarly, you can go for this one. I want you guys, I will show you this one. Sine of 180 minus theta. See, I told you sine function can be changed into cos function. Okay. Sine can be changed into cos function. Listen to me very carefully. I say this sine of 180 minus theta, I'll keep it sine theta only. Why, sir? Why, sir? Because a reason over here is, see, this is the vertical axis. This is the horizontal axis. We say this vertical axis changes the function, but horizontal axis does not change the function. It remains the same. See, guys, if I say it is sine of 180 minus something, 180 plus something, we say it will remain sine only. Because this, if you mention this 180 means this axis. 90, 270 means this axis. So we say that is the reason in this particular case, it will remain sine of 180 minus theta will remain sine theta only. Sine 180 minus theta will remain sine theta only. And if I say 180 minus theta, guys, this is 180 minus theta would be this one. This is plus some in this anti-clockwise direction. Clockwise is this one. 180 minus theta would be second quadrant. And in case of second quadrant, sine is positive. So we write over here, this is plus sine theta. Similarly, if I see over here, cos of 180 minus theta. Sir, whenever we say 180 or 360, it will remain cos only. It will not change the function. But if we see over here 90 minus theta, 270 minus theta, that will change the function. So it will remain cos theta only. Now you have to see whether it is positive or negative. We say it will be negative. Okay, because 180 minus theta is second quadrant. In second quadrant, cos is negative. That's why negative. This is your homework, all of these. Okay, this one also. All of these are your homework. Okay, let's move on to the next one. Binomial approximation. Guys, I'm not leaving any topic. Okay, so you have to understand each and every single thing. See, in this particular case, if I say I have got 1 plus x square, sir, it is like we have got a square plus, a plus b whole square. Over here, a is 1, b is x. Tell me, is this crystal and clear to each and everyone, whatever I told you? Changing the sign to cos. If you are getting any sort of confusion in this one, I request you guys to watch it later on at 2x. You'll get to understand. See, what is the value of 1 plus x square? You say, sir, it is a plus b whole square is simply a square plus b square plus 2ab. Similarly, we can use the same formula in this case. We say, sir, 1 plus x whole square will be, that is 1 square plus x square plus 2ax plus 2ax plus 2a. Now, guys, I want you guys to listen to me very carefully. If I say, if I say in this particular case, sir, 1 is much greater than x. Whatever is the value of this x, it is very small. It is much, much smaller than x. It is much, much smaller than 1. Okay. Now, guys, I have told you, if this x is very small, its square will be more small, and you are adding very small quantity to the very large quantity. If you add a very small quantity to very large quantity, it will not create any difference. It will not create any difference. It is 2x. It is 2x. It will not create any difference. It will not create any difference. Why? Because you are adding a bucket of water to the swimming pool. Sorry, you are adding a bucket of water to the ocean. Will it create any difference or no? That is the case over here. X square is very small, 1 is very large. So we say in this case, we can write, sir, 1 plus this x square would be, we can neglect this x square, we can write 1 plus 2x only. This is what we call the binomial approximation. Means if x is very much small than 1, we can neglect that quantity. So we can write directly 1 plus 2x. Over here in multiplication, we do not neglect. In addition, we neglect. Okay. Now listen to me very carefully. If I have over here 1 plus nx, if I have 1 plus nx in this case, if I have 1 plus nx in this case, listen to me very carefully. And if I say if 1 is much, much greater than x over here, 1 is much, much greater than x over here, can I write in this particular case, this 1 plus nx, 1 plus x whole raised power n, it will be simply, that is 1 plus nx. Yes, directly I'll just write, sir, it is 1 plus 2x. Over here, I'll just write it as 1 plus nx, 1 plus nx. Simply, similarly, if you have got this one, 1 plus x whole raised power minus n, in this case, you can write 1 minus nx. What is the condition? Condition is 1 is much, much greater than x. 1 is much, much greater than x. Just a second. Okay. 1 is much, much greater than x in that case. I hope this is clear. I hope this is clear to crystal and clear to each and everyone. Okay. Okay. Now, my dear friends, listen to me very carefully. Let's talk about the GP series. Is it clear till over here? Guys, tell me in the chats, please, please. From now onwards, if you see a quantity is very small as compared to the other quantity, you can neglect that in addition. You can neglect that in addition. I'm waiting for your fire emojis in the chats. Is it clear to each and everyone? Tell me, guys. Then only I'm moving forward. Is it crystal and clear to each and everyone? Is it crystal and clear to each and everyone? Tell me in the chats. Okay, okay. Great, great. And make sure you hit the like button, everybody of you out there, okay? Make sure you hit the like button. Now see, what is this GP series or geometric progression? Geometric progression means, let's suppose if you have got a number, we say 1. You multiply it with some number, let's suppose we multiply it with 2, okay? Now you multiply this number with the same 2. We say, sir, 2 into 2 becomes 4. Once again, you multiply this with the same number. We say 4 into 2 is, we say 8. Once again, you multiply this with the same number. We say, sir, it would be 16. Once again, you multiply this with the same number. 16 into 2 is, we say, sir, 32. And goes on, it goes on. This is what we call GP, geometric progression. If you have a number, if you keep on multiplying the number with the same number, like 2 into 1 is 2. Now 2 into 2 is 4. 4 into 2 is 8. 8 into 2 is 16. It becomes the geometric progression. Now, if I ask you to find the sum of all of these numbers, 1 plus 2 plus 4 plus 8 plus 32, we've said to find the sum of geometric progression. It is very difficult to find the sum over here, okay? But we have got a trick, we have got a formula. Sir, what is that formula? That formula is, we say, sir, sum is equal to. We say, sir, sum is equal to. We say a upon 1 minus a upon 1 minus r. Sir, what is a? A is, we say, first term, first term. We say r is, we say, common ratio, common ratio. A is first term, r is common ratio. Common ratio in this particular case, you have to find, I'll tell you how to find the common ratio. Common ratio will be simply take any term, divide it with the first. Like in this particular case, we say, sir, common ratio R is, let's suppose 8 divided by 4, that is 2. 2 is the common term, common ratio. What is the first term in this case? First term is 1. If you have got a geometric progression, if you have to add that, there is a formula, A upon 1 minus R. Now, let's solve this particular question, which is based on the geometric progression over here. Okay. This is also a GP. In this particular case, we have to find its sum. We have to find its sum. Listen to me very carefully. Sir, in order to find the sum of this GP, we say, sir, when it comes to the sum, we say it is simply A upon 1 minus R. In this case, we say, sir, A means first term. First term of this GP is 1. We say, sir, 1. And what is common ratio? That is R. How to find it? Take any term. Let's suppose I am taking, sir, 1 by 4. This is 1 by 4 upon. Take the first term before, take any term and divide it with the term which comes before it. 1 by 4 divided by 1 by 2. It is again 1 by 2. So common ratio comes out to be 1 by 2. You have to find, yes, you have seen this in the electrostatics. Now, my dear friends, if I have to find the sum over here, A upon 1 minus R, A is 1 upon 1 minus R in this case is how much? That is 1 by 2. So it is 1 upon 2 into 1 is 2, 2 minus 1 by 2, that is 1 by 2, so it will come out to be. So sum in this case has come out to be 2, so means sum of this is 2. Now this was the question which was previously asked in NEET and IIT. So if you have something like this, you have got a resistor. If you have got a resistor R, if you have got this resistor, these resistors in parallel, okay? We have to find the equivalent resistance in this case. Guys, first of all, can I say, sir, this resistance is, we say, sir, R. This resistance is, we say, sir, R plus, plus, plus. Now, these two resistors are in parallel. We know when the resistors are in parallel, their equivalent is, if you are getting any confusion in this one, directly remember it over here. Their equivalent is, sir, it would be R by 2. Okay. So we say this resistance plus equivalent of these two resistances plus equivalent of these four resistances. Then we say plus R divided by 4 plus. When it comes to, sir, this one, these are how many? These are 8 resistors. So we can say, sir, this is R divided by 8 and plus so on. Now. So these are the resistances. We have to add all of these resistances. We'll get the net resistance between A and B. We'll get the net resistance. Listen to me very carefully. We say, sir, R will take common in this case. It will be 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 plus so on. Don't you think this is a geometric progression? And it is exactly similar. It is exactly similar to this one. And we already calculated its sum, that is 2. So 2 is the sum. So I can write this is R multiplied by, we say, 2, that is 2R. So equivalent resistance of all of these combinations is, we can simply say, sir, that is 2. That is 2. Is this clear to each and everyone? Is this clear, guys? Now let's move on to the graphs. Let's move on to the graphs. See, when it comes to the graph, listen to me very carefully. We say, sir, we have got 2 axes over here. One is what we call the x-axis, and this is y-axis, and this is x-axis. Okay? Simply graphs, normal graph. If I ask you to plot the graph between y versus x, now what is the formula? Equation is y is equal to x. What does that mean? It means that if the value of x is 1, what is the value of y? Y is also 1. If I say x is equal to, y is also 2. Okay. Similarly, if I say in this case x is equal to 3, y is also 3. So we say the graph would be straight line. The graph would be straight line. Means when x is 1, we say y is 1. When x is 2, we say y is 2. When x is 3, we say y is 3 in that particular case. Okay. So this is how do we make the graph. Graph between y and x. If I say graph between s and t, so s and t. Okay. For y is equal to x, graph is this one. Similarly, if I ask you the question, plot the graph of y is equal to x squared. So in this case, you'll make this y on this axis, okay, and x on this particular axis, something like this is y and this is. And the graph in this case would be, just a second, graph in this case would be something like this is y is equal to square. Graph of y is equal to square. Tell me in the chats, is this crystal and clear to each and everyone, guys? Okay. Similarly, if I ask you to tell me the graph of y is equal to 2, y is equal to 2 means constant. See, in this case, y depends upon x. Means when x is 1, y will be 1. When x is 2, y will be 4. Okay, this is how y is varying with x. In this case, y also depends upon x. But here, we say, sir, y is constant, y is 2. So the value of y, we can make it something like this. This is y is equal to 2 over here. Y is equal to 2. Because this is constant. And if I say, sir, x is equal to 3 in this case, so the graph would be something like this. Okay. Is that clear? Is that clear, my dear friends? Let's talk about the slope now. Yes, I'll be teaching you the ray optics also in this particular series. Let's talk about the slope now. Very important. Maximum number of people have the confusion when it comes to the slope. Listen to me very carefully. I'll make you understand the slope today. I'll make you understand this particular chapter, that is slope, today. Sir, what does the slope mean? I have got the two lines over here. This is the first line, and this one is the second line. Okay. So this is the first slope, you say, and this is the second slope, you say. Okay. In this case, in both of these, this one and this one, can you tell me which one is more steeper, which is having more slope, which is having more steepness? Clearly we say, sir, this is having more steepness. So we say first is more steeper. Means first one is having more slope, first one is having more steepness. Now, I want you guys to calculate this steepness. I want you guys to calculate this slope. We say, sir, when it comes to the steepness, it is slope. Either you say, sir, steepness, or you say slope, it is one and the same thing. Guys, since you are saying that this is more steeper, it is difficult to climb this, it is difficult to move on this as compared to this one. This is having less steepness, sir. Now, we say, sir, in this case, the one which has more steepness has more perpendicular and less base. So we can write it something like this, sir. It is the one slope is directly proportional to the perpendicular and inversely proportional to. In this case, you see, sir, perpendicular is less, so slope is less. Base is more, so slope is less. Okay. So tell me, in trigonometry, in mathematics, which trigonometric ratio has perpendicular by base? Does sine have perpendicular by base, cos or tan? We can clearly say, sir, tan theta is equal to perpendicular upon base. This is the reason we say slope is equal to tan theta. Because slope is directly proportional to perpendicular, inversely proportional base. Same is the case with tan. That's why we say slope is tan theta. The one which has more angle will be having more tan theta, will be having more slope. As simple as that. Now, in this particular case, if I say, can you tell me what is the value of slope over here? Sir, we know slope is simply tan of theta. If you have got this line, in this line, sir, tan theta means this is perpendicular and this is base over here. So we say it is, sir, y divided by x. In case of yx graph, slope is y by x. In case of VT graph, slope is V by T. Okay. Now, my dear friends, I want you guys to focus on this one. Can you tell me slope between this point and this point? These 2 points mean slope of this portion of the line. See how you will say. The coordinates of this point are basically x2, y2. Coordinates of this point are x1, y1. What does x1 mean? X1 means this distance, x2 means this distance. Now, my dear friends, if you have to find the slope of this line, what will you do? Simply you say, sir, slope means tan theta, which is perpendicular by base. In this case, this would be the perpendicular of this line and this would be the base. And this perpendicular, you can say, sir, this is y2, this is y1. So this line would be y2 minus y. So you can also call it the delta y because change in y. And this would be delta x, that is x2 minus. So if you have to find the slope between these 2 points, you say, sir, delta y by delta x. So we say delta y by delta x. So from now onwards, you'll remember that slope between the 2 points, slope between the 2 points is, we say delta y divided by. Slope between the 2 points is delta y by delta x, y2 minus y1 upon x2 minus x1. Tell me in the chats, is this crystal and clear to each and everyone, guys? Is this clear to each and everyone? Guys, make the like count to 500. Okay. Okay. Everybody out there. Okay. Now listen to me very carefully. If we have got the two lines, this is the first line and this is the second line. And I am asking you, which one is having more slope? Clearly you say, sir, we know, sir, slope is equal to, we say, sir, tan of theta. And tan theta depends upon theta. The one which has more theta, slope will be having more. So we say clearly, sir, clearly in this case, this line has more theta, more angle. As compared to this line, it has only less angle. So we say in this case, slope of first line is greater than, we say, sir, slope of second. Slope of first is greater than slope of second. Slope of first is greater than slope of second. Okay, let's move on to this one. Can you tell me what is the slope of this line? We say, sir, slope is equal to simply tan of theta. Theta means how much it is making with the x-axis, how much angle it makes with the x-axis. In this case, it is making 0 degrees with the x-axis because the two lines are parallel. And in this case, tan 0 is, we say, sir, slope in this case is, we say, sir, 0. Slope in this case is, we say, sir, 0. And if you have to find the slope, in this case, we say, sir, 90. It is 90. And we say, sir, tan 90, we say, sir, in this case, slope is infinite. Slope is infinite. It is having the infinite slope. And one more important thing I just want to tell you. If you have, let's suppose the line something like this. In this case, theta is greater than 90 degrees. So whenever theta is greater than 90 degrees, less than 180 degrees, in that case, slope is negative. So we say slope for this line is negative. This is a decreasing graph. That's why slope is negative. And if you see on this line, at different points, slope will be same. Slope is same. Because at different points, we say, sir, angle is same. Angle is same. So slope at every point, slope at P is equal to slope at Q, slope R is equal to slope at S, slope at every. Slope of parallel lines is also same. Because these parallel lines are making the same angle with the x-axis. That's why slope in this case is also same. Okay. Now over here, come over here, my dear friend. If we talk about this line, in this case, we say, sir, this is the angle. Theta is less than 90. My dear friends, if theta is less than 90 degrees, means which quadrant we are talking about, sir? If we make the four quadrants over here, we say, sir, when it comes to the first quadrant, we say theta is less than 90 over here, because 90 degrees is this line. Theta is less than 90. And when theta is less than 90, means in this case all are positive, means tan is also positive. So in first quadrant, tan is positive, means slope is positive. That's why if I say, sir, if you have got a line something like this, in that case we say, sir, theta is less than 90. We say, sir, in that case you say slope is, we say. And now look at this particular thing. Sir, this line is having the theta greater than, we say, 90 degrees. And when theta is greater than 90 degrees, less than 180 degrees, means which quadrant? We are talking about the second quadrant, because this is 180 degrees, this is 90 degrees. If I say this angle, we say, sir, this is less than 180, greater than 90. So in this quadrant, we say, sir, tan is negative, tan theta is negative. And if tan is negative, means slope is negative. That's the reason I'm saying, guys, from now onwards, if you say, sir, slope of this graph, we say slope of this graph, you take positive. And if you see, sir, slope of this graph, you clearly say slope of this graph, you take as slope of this decreasing graph, you take as. Is it clear? Okay. Can you tell me the answer of this question? Which is having the more slope, this line or this line? Second or first? Sir, the one which has more angle will be having more slope. In this case, this is having the more angle as compared to this. So line 2 has more slope as compared to. Similarly, this is your homework. Not homework. This is, in this particular case, listen to me. You have got this line. This is the first line, and you have got second line. This line is making 30 degrees with y-axis. This line is making 30 degrees with x-axis. You guys are supposed to tell me slope of first divided by slope of second. Ratio. You guys are comment down the answer. Comment down. In this case, I want you guys to basically tell me the answer of this in the comments. Okay. Now, next is, come over here, my dear friends. In this case, could you please tell me, is slope positive or negative? Is slope positive or negative? Guys, this is y, this is x. This line is making how much angle with the x-axis? We say less than 90, so slope will be positive. M means slope. Okay. And in this particular case, if I say this is, can you tell me, in this case, is slope positive or negative? We say, sir, check the angle with the x-axis. This theta in this case is greater than, we say, sir, 90, less than 180. So slope is negative. Come over here. In this case, sir, we have to see how much angle it is making with the x-axis. You see, so this is the x-axis. Angle is, we say, sir, greater than 90. So we say slope is negative. In this case, sir, is the slope positive or negative? If this line is something like this, sir, this angle theta is less than 90 degrees. So we say less than 90 degrees. So slope in this case is. From now onwards, you'll directly remember. If theta is less than 90 degrees, we say, sir, slope M is positive. And if theta is greater than 90 degrees, less than 180 degrees, in that case, we say M is. You have to measure the theta with the x-axis. I hope all the questions from now onwards, in case of the slope, you will be able to solve. Now, my dear friends, listen to me very carefully. If I say variation of slope, what does variation of slope mean? Is it clear, or I am going fast? Am I going fast, or the speed is okay? Tell me in the chats. Am I going fast, or the speed is okay? Tell me in the chats, guys.
Okay, okay, okay. I want everyone to tell me. Everyone, please, please. Okay, okay. I'll slow down the speed. Okay. A bit, I'll slow down the speed a bit. Now see, now. If I say, let's suppose, if I say, let's suppose, if I say, let's suppose we have got, my dear friends, in this particular case, this is y versus x, and this is a straight line. If I say this is a straight line, this is a straight line. And listen to me very carefully. Sir, in case of straight line, we say slope at every point is same. Why? Because at every point it is making the same angle with the x-axis. That's why we say slope at every point is same. Okay, slope at every point is, we say, same. Slope at every point we say same. Okay, in case of a straight line. Now, my dear friends, listen to me very carefully. If I say I have got a graph over here which is curved, I have got a graph over here which is curved. This is the graph which is curved. And I want you guys to tell me, sir, in this case, is the slope constant or variable? We say, sir, since this is a curved graph, in case of a curved graph, we say, sir, slope is variable. And here slope is increasing. How to find the slope? See. If I say, tell me at this particular point, how much is the slope? You draw a line, something like this. You draw a line, something like this. Okay. And which should touch that point, draw a tangent and check how much angle it is making with the x-axis. That is the slope at a point. Okay. So to find slope at a point, draw a tangent. Draw a tangent at that point. In order to find the slope at a point, like in this case, I have to find the slope at this point. I'm drawing a tangent at this point and check how much angle it is making. Then you'll get the slope. At this point, you can clearly see, sir, slope at this point is greater than this point. Okay. So that's why we say slope is increasing, because angle at this point is alpha, angle at this point is theta, and we say alpha is greater than theta. So we say slope is increasing. Now, my dear friends, this is the case of curved graph. In case of a curve, we say slope is changing. So in this case, slope is increasing. Okay. But when it comes to straight line, we say slope at every point is same. Sir, slope in this case is positive, but at every point it is same. Now see. I want you guys to analyze this particular graph over here. Guys, this is the graph that I want you guys to analyze. If I say at this particular point, you have to tell me what is the value of the slope. You say, sir, draw a tangent at this point and check how much angle it is making with the x-axis, and you will get the slope at this point. If I say, sir, this tangent is making, sir, we say, let's suppose 45 degree with the x-axis. So slope at this point is tan 45, that is 1. Okay. Now, if I want you guys to tell me the slope at this point, you say, sir, draw a tangent at this point, check how much angle it is making with the x-axis, you'll get the slope. Sir, this line is parallel to x-axis, so slope at this point is 0. At this point, slope is positive. Why? Because theta is less than 90 degrees. Similarly, if I ask you to tell me the slope at this point, what will you say? You'll draw a tangent line and check it is making the angle. Theta is greater than 90 degrees, because this much is the 90. It is greater than 90 degrees. So we say slope is negative. So in case of a curved graph, if you have to find a slope at a point, you draw a tangent at that point. Okay. So my dear friends, initially slope is positive, then it is 0, then we say it is negative. Okay.
And we say in this case, here slope is decreasing. Here slope is decreasing. Why slope is decreasing? Because it is positive, 0 and negative. Now come over here. Come over here. In this case, can I say, sir, when it comes to this point, if I want you guys to find the slope at this point, see. It is similar. It is similar. It is similar. It is one and the same thing. At this point, it would be positive, 0 and negative. Now come over here in this case. Sir, when it comes to this point, could you please tell me how much is the slope at this point? You say, sir, draw a tangent. Check how much angle it is making with the x-axis. Theta is greater than 90 degrees. So we say slope at this point is negative. Because whenever the theta is greater than 90, we say slope is negative. Okay, we say slope is negative. And my dear friends, now at this particular point, tell me what is the slope at this point. Sir, draw a tangent. This tangent is parallel to x-axis, so slope at this point is 0. Now, at this particular point, we say draw a tangent at this particular point. Okay, so in this case, we say, sir, theta is less than 90, so slope at this point is positive. So we say in this case, slope is increasing. Slope is increasing. Why? Because initially it was negative. From negative to positive. From negative to positive means slope is increasing. Is that clear? Let's come on to this graph. In this case, we say, sir, at this point, we say slope is 0. If you draw a line which is parallel to x-axis, it is 0. At this point, this much is the slope, and this slope over here is, we say, sir, positive. So slope over here is m is 0, and in this case, m is, we say, sir, positive at this point. So we say in this case also, slope is increasing from 0 to positive, so slope is increasing. Slope is increasing. Is this clear? This is the graph where slope is decreasing. This is the graph where slope is increasing. This is the graph where slope is increasing. Similarly, you can check for this graph. Is the slope increasing or is the slope decreasing? Is the slope increasing or is the slope decreasing? See, when it comes to this graph over here, at this topmost point, we say, sir, slope is 0. At this point initially, sir, slope is m is positive. So we say in this particular case, slope is decreasing. We say it is initially positive and it becomes 0, it is decreasing. Now in this case, can you tell me is the slope increasing or decreasing? We say, sir, initially the slope is, we say, sir, negative, then it becomes 0, then it will become positive, so slope is increasing. Okay, because it is moving from negative to 0. Over here it is negative and it is 0. It is moving from negative to 0, so slope is increasing. M in this case is increasing. And over here, can you tell me is the slope increasing or decreasing? In this case, we say, sir, over here it was, we say, sir, 0. And then at this point, if I say draw a line, this line theta is greater than 90 degrees, so slope will be negative. So if the slope is moving from 0 to negative, so slope is decreasing. Slope is decreasing. I hope this is clear. I hope this is clear. I hope this is clear. Is this clear? Is this clear to each and everyone? Is this clear to each and everyone, guys? Tell me in the chats. Tell me in the chats. Is this clear to each and everyone? All the people out there, guys. Is this clear to each and everyone? Now see. If I say, I hope the slope is crystal and clear. Slope is crystal and clear. Slope is crystal and clear. Let's suppose I say I have got over here. This is, we say, sir, y-axis, and this is, we say, sir, x-axis. This is y-axis and this is. And in this particular case, I told you, sir, I have got a line over here. This is making the angle theta. And what is the value of slope? You say, sir, slope is simply tan theta. And that is simply, if I say theta is, let's suppose, 45 degrees, Then you say tan of 45 degrees, which is equal to 1. This is the case we are done with. All the cases in case of slope we are done with. Okay. Now. I want you guys to exactly focus on the concept which is differentiation. The concept which is differentiation. Okay. The concept which is differentiation. Okay. Okay. Tell me. Okay. Now see. Let's move on to the concept of differentiation right now. I hope till over here everything is clear. I hope till over here everything is crystalline. Okay. If 45 degree with the y-axis, then you have to see with the x-axis. That is also 45. Okay. You have to measure with the x-axis. Now listen to me very carefully. So guys, is this crystalline clear? Let's move on to the differentiation concept right now. See, when it comes to the differentiation, see, let's suppose if I say this car is moving from this point to this point. This car is moving from this point to this point. And if I ask you, how much was the speed of the car when it moved from A point to B point? Let's suppose it is your house and it is your friend's house. When the car moved from your house to your friend's house, we say, how much was the distance? How much was the speed? You say, sir, when it comes to the speed, listen to me very carefully. We say, in order to find the speed, we can say total distance traveled upon total time taken. Okay. Total distance traveled, we can say, sir, delta D. From this point to this point, let's suppose total distance traveled is delta D divided by total time taken. Let's suppose that is delta T. Sir, this is how we find the speed. Total distance traveled upon or total displacement traveled upon total time taken. You say, sir, this will be 100 minus 0. Because finally, when the car is at over here, it has covered how much distance? 100 kilometers. 100 minus 0 minus how much time? We say, sir, 10 minus 0. So it would be simply that is 10 kilometer per hour. So this was the speed of the car when it was moving from A point to B point. Total distance traveled upon total time taken. As simple as that. Total distance traveled upon total time. Now, this is the speed, which is what we call, this speed is the average speed of the car. Average speed of the car from A to B. This is the average speed of the car from A to B. Now, my dear friends, listen to me very carefully. If I want you guys to tell me, listen to me very carefully. What was the speed of the car at this particular instant when it was exactly at this point? Guys, you are saying when I was moving from my house to my friend's house, sir, total average speed was, we say how much? 10 kilometer per hour. Sir, at any particular point, how much was my speed? Let's suppose when I stopped at, when I was crossing the choke, okay? At that point, what was my speed? Speed at any particular point, that's what we call the instantaneous. So, how to find this instantaneous speed? Now, this became the problem. To solve this problem, we introduced the concept of differentiation. Now, to find the speed at a particular instant, at any particular instant, we say we use differentiation. So differentiation will help us to find the speed at any particular point. Sir, when it comes to the average speed, we say average speed is delta d by delta t. But instantaneous speed over here, that is simply, sir, that is we say simply dd divided by dt. Small change in distance upon small change in time, this will give us the speed instantaneous, and this is what we call differentiation. Okay, so differentiation helps you to find the speed, or we say rate of change of displacement with respect to time over here at any particular point. Differentiation helps you to find the speed at any particular point. Guys, if I say at from A point to B point, how much is the speed? You say, sir, delta d divided by delta t. But at any particular point, we say, sir, how much is the speed? That is dd by dt. How did you exactly got this? We say with the help of the differentiation. Differentiation helps us to find the rate of change. Here, what is this? What is this actually? This is rate of change of displacement with time at any particular instant. With the help of differentiation, we got this. Okay. Is that clear? Is that clear? Okay. Now, we can also write it something like this. See, when it comes to the differentiation, this is in terms of displacement and time. We can also write this dy divided by dx. Okay. This is also what we call the differentiation. In reality, what is this? This is rate of change of y with respect to x. How y? With what rate y is changing with x? Guys, over here, this is delta d by delta t. That is 10 kilometer per hour. Means every hour it was covering how many kilometers? 10 kilometers. Okay, so this is also the rate of change. Rate of change of what distance? With respect to time, 10 kilometers every hour. If it was 20, we said 20 kilometers per hour. At any particular point, you have to find rate of change. How do you find? You say, sir, with the help of differentiation. And that is also what we call the dy divided by dx. Is that clear? Please tell me in the chats. Is this clear? Differentiation helps us to find the rate of change. We say differentiation helps us to find rate of change at any particular instant. In the chats, I want you guys to tell me in the chats, is this crystal and clear? In case of displacement and time, it will help us to find the speed at any particular point. Okay. Now, the graphical representation of differentiation. What does graphical representation of differentiation mean? Listen to me very carefully. On this axis, you have y. On this axis, you have x. Let's suppose the graph is something like this. My dear people, listen to me very carefully. Listen to me very carefully. If I take this particular point, can you tell me, sir, what is the slope of this line between the 2 points? Find the slope between the 2 points over here. You guys are supposed to tell me the slope between the 2 points over here. Between this point and between this point. You guys are supposed to tell me the slope between the 2 points. Listen to me very carefully. Sir, we know, sir, in this particular case, you say, sir, either you say average or you say, sir, slope over here between the 2 points. What is that? That is delta y divided by delta x. We know, sir, slope is nothing but delta y divided by delta x. Okay. Between the 2 points, we have studied this. Okay. Or you say, sir, it is y2 minus y1 divided by, we say, x2 minus x1. Or either you call it the tan theta, one and the same. Okay. Now, my dear friends, I want you guys to tell me what is this delta y by delta x? What is this delta y by delta x? This is rate of change of y with respect to x. Either you call it slope, or you call it the rate of change, or you call it the delta y by delta x. One and the same. Now, come over here. I want you guys to tell me the slope at this particular point. Now, slope at a particular point is also given by differentiation. So differentiation helps us to find the rate of change. Guys, listen to me very carefully. But at what point? At any particular point. Now, if between the 2 point slope is delta y by delta x, or you say, sir, slope is delta y by delta x, or you say, sir, rate of change of y with respect to x, one and the same thing. Can I say slope at a particular point is? We say in this case, slope at a particular point is. Guys, listen to me very carefully. Can we say it is dy divided by dx? Because, see, compare it with this one. Sir, speed between the 2 points, this point and this point, is delta d by delta t. Slope at any speed at any particular point is what? We say, sir, this small d by small dd by dt. So how did you get this differentiation? Because differentiation helps us to find the rate of change. This is rate of change at any particular point. Same is the case over. Come in graphs. In case of graphs, if we have to find the slope between the 2 points, we'll use the formula delta y by delta x. Simply, sir, tan theta. Now, if we have to find the slope at a point, we say, sir, we'll use differentiation. Because differentiation helps us to find the rate of change, and rate of change over here is slope. Guys, what I'm trying to say in this case is, either you say slope, or you say, sir, dy by dx, or you say, sir, rate of change of y with respect to x. It is one and the same thing. Over here, I am telling you in terms of y and x. I can also tell you in terms of v and t, dv by dt, that is acceleration. So this is rate of change of acceleration with time. That is also the slope. Tell me, guys, please in the chats. Please in the chats. Please in the chats, everybody. Or you say, sir, it is tan theta. Or you say, sir, it is tan theta 1 and. Tell me in the chats, is this clear? Is this clear? I'm waiting for your comments only. Please. Is this crystalline clear to each and everyone? Is this crystalline clear to each and everyone? Is this crystalline clear to each and everyone, guys? Tell me, everybody out there, is this crystalline clear? Make sure you hit the like button, guys. Tell me in the chats, is this crystalline clear? Okay. Simply, differentiation is rate of change of y with respect to x at any particular point. Okay. Now, let's move on. Let's move on to this one. Let's move on to this one. Now the question is how to differentiate. Now this is simple. Everybody knows it. How to differentiate. See. Let's suppose if you have got y is equal to x raised power n. Y is equal to x raised power n. And you have to differentiate this term. Okay. How do we do the differentiation by dx? Everybody knows it. See, sir, differentiation of this will be simply this power down. Take this power down, that is n down, then power minus 1, n minus 1. Let's suppose we have got the question over here, y is equal to x square. Y is equal to x square. We have to do its differentiation. Okay, we have to do it. What does differentiation mean? To find the rate of change. Okay. So what does that mean, sir? dy divided by dx in this case is power down, power minus 1. That is 2x 2 minus 1. N down, n down. Then we say n minus 1. 2x 2 minus 1. That is 2x 2 minus 1 is 1. That is 2x. Now, differentiation of this 1 by x. Can you tell me in the chats what is the differentiation of 1 by x over here? Everybody out there? What is the differentiation of 1 by x? Come on. So we say, sir, if we talk about this, we say dy divided by dx is equal to differentiation of 1 by x is, can we take this x in the numerator? This will be x raised power minus 1. So we can write it, sir, power down, that is minus 1 into x, power minus 1, minus 1, minus 1. So it will be, sir, minus x minus 2. Minus x minus. Is that clear? Okay. Can you tell me the differentiation of this one? You can also write it something like this, x raised power 1 by 2. Because the value of root is 1 by 2. The value of root is 1 by 2. Okay. And if we have to find its differentiation, dy divided by dx, we can write power down, power minus 1. That is x raised power 1 by 2 minus. That is 1 by 2 down, 1 by 2 minus 1. Okay. Okay. Is that clear? Everybody in the chats? Okay. Now solve this further on and you'll get the answer. In this case, what is the value of dy by dx? That is power down. Power is 3 by 2. This is 3 by 2 down. Then we say x power minus 1. 3 by 2 minus. Power down, power minus 1. Guys, when I was explaining the slope, did I go more fast? Because this gives me some sort of unsatisfaction that in this class I was a bit fast, so I won't be able to sleep now. Please tell me in the chats, was it fast or the speed was okay or it was perfectly fine? Tell me, everybody. Okay. Okay, great, 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 great. 98% people are saying it was fine. Okay, great, great. Okay, great, great. Cool, cool. Now, differentiation of trigonometric function. Differentiation of trigonometric function. Listen to me very carefully. Over here, if you have, let's suppose, got y is equal to sine x, and you have to differentiate the sine x, we said differentiation of sine x is cos x. Okay. Similarly, if you have cos x and you have to differentiate it, we said differentiation of cos x is minus sine x. Similarly, if you have tan x, differentiation of tan x is, we say, sir, sec square of x. You have to remember all of these. And if you have e raised power x, and if you have to differentiate it, its differentiation is e raised power x only. Now come over here. Now, my dear friends, if you have y is equal to cot of x, and if you have to differentiate it, its differentiation is cos square of x. Sorry, cosec square of x. And if you have cosec x, its differentiation is cosec x into cot x. Cosec x into cot x. Similarly, if you have y is equal to sec x, its differentiation is sec x plus tan x. And if you have, sir, log of x, what is the differentiation of log of x? We say its differentiation is 1 by x. You'll have to remember these directly, okay? Now, my dear friends, Let's suppose if you get a question something like this, how to solve this particular question. Y is equal to 5x cube. In this particular case, when it comes to the differentiation dy by dx, we say simply, what is the first thing that you guys will be doing? Take this constant, 5 is the constant over here, this 5. This 5 is the constant, take this constant out, okay? Then you have x cube. And in case of x cube, you will be using this formula, x raised power n is equal to n down n minus 1. That is 3 down x raised power 3 minus 1. 5 threes is 15 x square. 3 minus 2 is 3 minus 1 is 2. Now over here, in this case, y dy by dx is equal to, this is 2 sine x. Take this 2 out. What is the differentiation of sine x? We say, sir, it is cos of x. So it is 2 cos of x. Simply take the constant out and do the differentiation. Addition rule, y is equal to a plus b. If you have got the equation something like this, how to differentiate? How to differentiate? Let me tell you. Let's suppose you have got 4x square plus you have got 2x. 4x square plus 2x. And we said differentiation dy by dx is equal. First, we'll do the differentiation of this, that this is a and this is b. First, we'll do the differentiation of this, then we'll do the differentiation of this. Now, differentiation of 4x square is how much? We say, sir, take this 4 out. And then, in case of x square, power down, x raised power 2 minus 1, power minus 1. Then we say, sir, differentiation of 2x will be directly writing the 2 over here. If you have got 3x, will be directly writing 3. 4x will be directly writing 4. So it will be 4, 2 is 8. 2 minus 1 is 1. 8x plus 2. 8x plus 2 is the differentiation. So whenever you have addition rule means, if you have got y is equal to a plus b, and you have to find the differentiation, what will you do? You'll first differentiate dA by dx plus we say, sir, dB divided by. First you differentiate a, then you differentiate b. Same is in case of subtraction. In this case, if we have to find dy divided by dx, if we have to find dy by dx, first we'll find the differentiation of sine x. Sir, differentiation of sine x is, we say, sir, cos of x minus. What is the differentiation of x square? Sir, take this 2 down, then x 2 minus 1. Power down, power minus 1. So this is nothing but cos of x minus 2x. Is this clear till over here? Is this clear till over here? Now we'll move on to the multiplication rule. Is this clear till over here? You can have, I'll send you the notes in the Telegram, okay? You can have so many number of questions which are there to practice. I'm just showing you the rule only in these. I'm just showing you the rule only in these. Okay. Now see. Let's suppose you have got the two functions over here, a and b, which are in the multiplication. You have got the two functions a and b which are in the multiplication. Listen to me very carefully. No, I'll not be taking the vectors. Basic mathematics without the vectors. Okay. See, if you have got a into b, this is multiplication rule. In this case, if you have to differentiate it, what will you do? You will keep this a as it is over here. Then you will do the differentiation. Then you will do the differentiation of b, dB by dx. Okay. And then you will keep the b as it is over here. And then you will do the differentiation of a. Like. This you can consider a over here. This you can consider b over here. X square is a. And this b is sine x. And if we have to differentiate this dy divided by dx, you can simply say, sir, keep this a as it is. So let's suppose we'll keep the x square as it is. Okay. Then differentiation of sine x. What is the differentiation? dB by dx. Differentiation of sine x we can write over here, that is cos of x. Okay. Then we write plus. Keep the b as it is. Keep the b as it is. B in this case is sine x, sine of x. Okay. Then we say differentiation of a. A is x square. Differentiation of x square is 2x. So we can write this as x square cos of x, then plus 2x sine of. This is the differentiation. Okay. If you have, keep the a as it is, then differentiate b, plus keep b as it is, then differentiate a. Now we have the division rule. Division rule. Let's suppose if you have a function y is equal to a divided by b. How to differentiate this? First, you will do the differentiation of a. Differentiation of a. dA by dx. This means differentiation. If you have y, if I say its differentiation is dy divided by dx with respect to x. So we say, sir, dA divided by dx. And then we say, sir, keep b as it is. If you have got a divided by b, in this case, what will you do is that you differentiate this a and you will keep the b as it is. You will keep the b as it is. Then we say minus. You will keep the a as it is and differentiate b. Differentiate b divided by b square. The example is over here. Let me show you this particular example over here in order to solve this particular question. See, in this particular case, we say this is a divided by b. Let's consider this as a and let's consider this as b. Okay. Sine x in this case is considered, let's a, and x square we are considering in this case as b. Now listen to me. When it comes to, sir, dy divided by dx, dy divided by dx, listen to me very carefully. Sir, dy by dx means, sir, if you have a divided by b, what does formula say? First, do the differentiation of a. What is the differentiation of sine x? We can write, sir, differentiation of sine x, or you can write it d by dx of, we can write sine x, differentiation of sine x, multiplied by, keep this b as it is. B in this case is what? B in this case is x square, so keep x square as it. Then we say minus, keep sine x as it is. Okay, a as it is, differentiation of b, that is d by dx of, we say, sir, x square, divided by, we say, b square. B is x square whole square. Can we write it? See. Now differentiation of sine x is, we say, sir, cos of x. And then we write x square minus. Then we write this sine x as it is over here. And differentiation of x square is, we can write 2x, power down, power minus, whole divided by, we can say, sir, x raised power 4. You can reshuffle it. You can write it something like this. That is x square cos of x minus 2x sine of x divided by x raised power. This would be the final answer in this case. Is this clear? Tell me in the chats, guys. Is this clear to each and everyone? Is this clear, guys? Tell me in the chats, everybody out there. Is this crystalline clear, guys? In the chats, Let me know with the fire emojis. And you have not liked the session yet, guys, like the session as soon as possible. Make the like count 600 plus. Make it 600 plus. Okay. Now let's move on to chain rule of differentiation. What does chain rule of differentiation say? Listen to me very carefully. When it comes to the chain rule of differentiation, guys, This is also called the outside inside rule of difference. Outside inside rule of difference. What does that mean? Let's suppose you have got an equation. You have got an equation something like this. You have got an equation something, and you have to differentiate it. Find dy divided by dx. Let me show you how do you differentiate this equation. What is this? This is sine of x square. It is not sine of x. It is sine of x square. How do we differentiate? If it was sine x, we would have simply said sine x, differentiation of sine x is cos x. But is sine of x square. In this case, what will you do is that you will do one thing, that is dy by dx is. First, you will do the differentiation of the whole. Okay. Consider this as x only. Consider this x square as x only. So what is the differentiation of sine x? See, what will you do? First, you will do the differentiation d by dx of sine of x square. Okay. First, you will do the differentiation of whole term. Then you will do the differentiation of then d by dx of what is inside this angle. What is inside this angle? That is x square. This is what we call the outside inside rule. First, you will do the differentiation of the whole outside. Then you will do the differentiation of this, which is in the inner part. This is how do we exactly do it. So we say, sir, differentiation of sine x. Consider this x square as x only. So we say it is simply that is cos of x square. If it is x square, you'll put it x square. If it is something else, you'll put it something else. Then differentiation of x square. Sir, that will be 2x. That will be 2x. So it is simply 2x cos of x square. 2x cos of x. Now, if I have the same question over here, let's suppose I have the question y is equal to cos of, we say x cube, cos of x cube. You have to find its differentiation. What will you do? You will first say, sir, dy by dx in this case is, first you will do the differentiation of the whole term, that is d by dx of cos of x cube. Then the differentiation of whatever is inside the angle, that is d by dx of, we say, sir, x cube separately inside differentiation. That's why we call it outside inside rule, chain rule. So we say, sir, differentiation of cos is, we say, sir, minus sine of x cube. Now differentiation of x cube is, we say simply it is, sir, power down 3 and x power minus 1, 3 minus 1. So it will be minus x minus sine of x cube, and then we say 3x. Is this clear? Is this clear? Can you differentiate this one? Sir, e raised power x, differentiation of e raised power x is also e raised power x. Its differentiation is e raised power x only. See, in this case, what will we do is that in order to find dy by dx, listen to me very carefully. First, we'll do the differentiation of e raised power minus alpha x. Then, whatever is inside this, okay? So then we say differentiation of d by dx of, we say, sir, it is minus alpha x. So in this particular case, we say differentiation of this is minus alpha x and differentiation of this is minus alpha over. Okay. Same is the case over here. If I say, sir, dy divided by dx, first you will do the differentiation of this one. That is 4 2x square plus 3 4 minus 1. Because you are considering this as x. Power down, power minus 1. Then you are doing the internal differentiation. Internal differentiation of which one? This one. That is for 2x square is 4x. Okay. So this would be 4 into 2x square plus 3 cube. This is this clear? Tell me in the chats, everybody out there. Tell me in the chats, everybody out there, guys. Is this crystalline clear to each and everyone?
Is this crystalline clear to each and everyone out there? Now, we will have to do the double differentiation. What does double differentiation actually mean? Double differentiation simply means differentiating a function twice. Differentiating a function twice means double differentiation. Let's suppose we have got y is equal to x cube and we have to differentiate this function. So what will we do? We say, sir, dy divided by dx is equal to power down, that is 3x, 3 minus 1, that is 3x square. So this is the differentiation. We did it once. I want you guys to do it once again. This is how do we write d2y divided by dx2. Differentiating a function twice. So we can write it something like this. So we have to differentiate this now. Take this 3 out. Then you have x square. Power down. That is 2. Okay. X 2 minus 1. 3 into 2 is 6x. We can simply say over here 6x. So double differentiation of x cube is 6x. Simply. Can you tell me what is the double differentiation of this one? This I'll give you as homework. Double differentiation of this one. And this is one of the best questions over here today. This also I'll give you as homework. If we have y is equal to x square, we have y is equal to x square. In this case, you have to find dy by dx. That is differentiation of this y with respect to x. And you have to find the differentiation of y with respect to t. Okay, this is the question. I want the answer of this question in the comments. Comment down below. Comment down below. Okay. Now comes the concept of maxima and minima. Is this clear till over here? Let me know in the chats, guys, if this is crystalline clear. Okay. Now we have the maxima and minima and then integration. It will take 30 minutes and we are done with this one. It will take 30 minutes. Guys, see. Let's suppose I have given a graph over here that is y versus x. It is y versus x, something like this. Okay. The graph is between y versus, we say over here, x. My dear people, this graph is, let's suppose, something like this. This is the graph which is given over. Can you tell me in this particular graph which one is the highest point, which one is the maximum point? You say, sir, this one is the maximum point in this graph. And if I say, which one is the lowest point in this graph? You say, sir, this one is the lowest point in this graph. So we say this is what we call the maxima and this is what we call the minima. As of now, you just remember it. This is what we call the maxima. This highest point is what we call the maxima. And this lowest point is what we call the minima. Okay. Now I want you guys to find the slope at maxima and minima. Find the slope at maxima and minima. Sir, if we draw a line at this maxima, don't you think, sir, this line is parallel to x-axis, so slope will be 0? Slope will be 0 at maxima. Similarly, if we draw a point tangent at this line, at this point, minima, you can clearly see slope at this point is also 0. Slope means, guys, I have told you, slope means dy by dx, because we know, sir, when it comes to the slope is dy divided by dx. Slope at a point is dy by dx, already discussed. So in case of maxima, dy by dx is 0. In case of minima, dy by dx is 0. Okay. In case of maxima, dy by dx is 0. In case of minima, dy by dx is 0. So can I just write over here? In case of maxima
and minima, we say dy by dx is equal to 0. Why? Because slope is equal to 0 in case of maxima and minima. Now, my question to you is, my dear friends, if we want to find particularly, which one is maxima and which one is minima, because at both the points slope is 0. Which one is maxima and which one is minima? How to find that? Listen to me very carefully. We can say, sir, this upper part, this upper bowl is, we say, sir, maxima. See, can you tell me in this particular case, sir, initially slope is positive? Already discussed. Sir, draw a line over here which makes less than 90 degrees. So slope initially is positive. If I find the slope at this point is positive. Slope at this point is 0. Slope at this point will be negative. So we say it is positive, 0, negative. Can I say in this case, sir, m is decreasing? Slope in case of maxima is decreasing? Yes, sir. So if slope is decreasing, my dear people, we say, sir, dy by d2y by dx2, double differentiation at maxima will be negative. My dear friends, if I say, directly remember, if I say dy at maxima and minima, we say dy by dx is equal to 0. Now, particularly when it comes to the maxima, we say, sir, d2y by dx2 is double differentiation, double slope is, we say, sir, if that is negative, then it is called maxima. And when it comes to the minima, in case of minima, d2y by dx2 is positive. d2y by dx2 is positive. Guys, let me just show you over here. What I'm trying to say is that, I'll tell you over here. When it comes to maxima, maxima means highest point in the graph. We say, sir, dy by dx, either you call it the slope or you call it the differentiation. First differentiation is 0. Either or, minima, sir, in case of minima, we say dy by dx is also 0. Because in case of minima, dy by dx is 0. In case of maxima, dy by dx is 0. How to find which one is maxima and which one is minima? If you differentiate again, if you double differentiate, we say, sir, d2y divided by dx2. If this comes out to be negative, then it is maxima. And if double differentiation d2y by dx2 comes out to be positive, then it is minimum. Tell me, is this clear? If slope decreases, yes, that is what I'm trying to say. If slope decreases, then it is maxima. Guys, in this case, in case of slope, see, over there, this is the reason I was explaining you. Slope is first positive, then it is 0, and then it is negative. If slope is decreasing, then we say it is maxima. See, then it is maxima. Then we write it is maxima. Okay. And if see, slope initially is negative. See, at this point, slope will be negative. Slope at this point is 0. Slope at this point is positive. So if slope is increasing, if m is increasing, then it is minimum. Directly, this is the trick that you guys are supposed to. Hey, tell me, guys, is this clear? Is this clear to each and everyone? Tell me, is this clear to each and everyone, guys? Is this clear to each and everyone? Okay. Now, let me solve a question on this one. Let's suppose we are given this function. Y is equal to x square minus 4x plus 5. And in this particular case, we are supposed to find maxima or minima. You have to find the maxima or minima. See, So we are given y is equal to x square minus 4x plus 5. X square minus 4x plus 5. Okay. Now, my dear friends, we say at maxima or minima, we say, sir, dy divided by dx is equal to 0. We say dy by dx is equal. At maxima or minima, we say dy by dx is equal. Okay. Let's find the dy by dx. So we said differentiation of this is, we say, sir, differentiation of x square is 2x minus differentiation of 4x is 4. Okay. And make this is equal to 0. Make this is equal to 0. Okay. So we say, sir, 2x is equal to 4. We say x is equal to 2. Means at x is equal to 2, dy by dx is coming out to be 0. So we say, so at x is equal to 2, either at x is equal to 2, we say dy divided by dx is equal to 0. So it is either minima or maxima. It is either minima or maxima. Now, how to find if it is maxima or minima? How to find if it is maxima or minima? See, it now to check for maxima and minima. Now to check for maxima and minima. What we have to do? We have to double differentiate. We have to double differentiate. We have to double differentiate. Now, that is, so we'll find d2y divided by dx2. We'll differentiate again. See, first differentiation is this one. Now we have to differentiate it again. So we say if we differentiate this 2x, 2x minus 4 again, what is the differentiation of 2x minus 4? That is 2 only. And this 2 is, we say, sir, positive. If d2y by dx2 is coming out to be positive, see, if d2y by dx2 is coming out to be positive, then we say it is, minima. So it is minima. So it is minima at x is equal to 2. Sir, what are you trying to say? Let me show you over here. See, guys, if you are saying, sir, at this maxima, this is the maxima, you say, sir, at this maxima, value of x is x1. So means at x1, x1 will be having some value, 2, 3, 4. At x1, y is maximum. At x2, y is minimum. Same is the case over here. We say, sir, at x is equal to 2, at x is equal to 2, y is minimum. The value of y is coming out to be minimum. Is this clear? Is this clear? Tell me in the chats. Is this clear? Is this clear? Let's move on to the integration. Concept of integration. See, class will end in few minutes, like 10-15 minutes more. 10-15 minutes more and we are done. Okay. Is this clear till over here? Tell me in the chats, guys. Shall I explain maxima and minima once again, or is it is clear? Simply, at maxima and minima, maxima is the highest point on the graph, minima is the lowest point on the graph. At maxima and minima, dy by dx is 0, slope is 0. And at maxima, d2y by dx2 is negative. At minima, d2y by dx2 is positive. Okay, this is the concept. Now let's discuss the integration. Let's suppose in this particular case, the car is moving, okay? This car started from A point to B point. It is moving with a speed of 100 kilometer and it took time t is equal to 5 hours. And I am asking you the simple question. What is that? How much is the distance traveled from A to B? We say, sir, distance traveled from A to B. How much is the distance traveled from A to B? See, sir, when it comes to the distance traveled, we say, sir, velocity is equal to distance upon time. Sir, over here, distance is equal to velocity into time, V into T. Now, what is the value of velocity? That is 100 kilometers. So we say distance in this case is, or displacement is, we say 100 multiplied by 5, that is 500 kilometers. So from A to B, distance is 100 kilometers. Cool, 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 normal formula. Now, if the same car moves with a variable speed, in this case, I'm saying the speed of the car is constant. Here it is 100, here it is 100, here it is 100. At every point, the speed is same. But if I say this car is moving with the variable speed, here let's suppose it is 100, 200, 50, 30, 40, 500, something like that. Something like that. How to find the speed, how to find the displacement in this case? So it is difficult to find the displacement in this case. Okay. So to find, we say displacement here. We cannot use this formula because this formula is used when speed is constant. But in this case, the speed is not constant at all. The speed is not constant at all. Okay. So my dear friends, listen to me very carefully. What we are going to do is that we'll take a small distance. Okay, very small distance. So can I say for this very small interval, let's suppose dt, I'm taking the very small interval dt. For this very small time, its speed would have been constant v. Yes. Array, from this point to this point, it is variable. At any particular point, it is 10 km per hour only. Okay, from this point to this point. So we say at very small time, its speed is constant. Now, if speed is constant at very small time, we can find the displacement. Sir, we can use the same formula. Displacement is equal to, we say, sir, displacement is equal to velocity into time. In this case, the displacement covered will be also very small because for very small time, displacement covered will be small. So let's call that dd is equal to velocity into, how much is the time? We say, sir, dt. Time is dt. So this is the small displacement covered. Now to find, guys, this is the small displacement covered. So we say, sir, dd is equal to v dt. Now to find the displacement from A point to B point, sir, tell us some trick to find the displacement from A point to B point. I'll repeat it. Guys, I'm saying that for very small time, its speed would have been constant. Very small time means dt. So for dt time, its speed is v. So for this time, how much displacement it has covered? Sir, that is also very small. That is dd, small displacement. That is equal to velocity into small time. Okay. Now to find total displacement. Now to find total displacement, we use integration. To find total displacement, we use integration. My dear people, listen to me very carefully. So we say displacement total. We can say, sir, integration of dd is equal to integration of vd. So integration helps us to find the total displacement in this particular case. Okay. I hope you got the feel of integration. Now, the point is area under the curve. Now, let me give you the feel of integration graphically. Let's understand integration graphically. See, over here, integration helped us to find the total displacement when the speed was variable. Okay. My dear friends, in case of graphs, how to understand integration? Let's suppose we have the graph between y versus x. Okay, this is the graph, something like this is length and this is breadth. Can you tell me the area under this graph? Can you tell me the area under this graph, this line? You say, sir, that is area of rectangle, and that will be simply length multiplied by this breadth. Length multiplied by breadth will be the area. But if we have the graph something like this is the curved graph. How to find the area under the curve? How to find the area under the curve? Since this is not a rectangle, this is not a triangle, you cannot use the formula. What we can use, what we can do instead, I want you guys to basically take a small strip, infinitely small. Okay, take a small strip. Cut this graph into small strips. And the width of this is extremely small. That is dx. That is how much? We say, sir, that is dx. That is dx. Dx is the width. And how much is the height or the length of this graph? Let's suppose it is y. It is y. Now, this strip, small, infinitely small strip, behaves like a rectangle. Area of the small strip I can write over here. We say, sir, area of small strip. So that will be also small. That is dA. And that is length into breadth. Length is how much? That is y. And breadth is that is dx. Y. So this is the small area. Now, if we want to find the total area, to find, we say total area. So if we want to find the total area from this point to this point, that is the area under the entire curve. So we'll use integration. Use integration. So we say, sir, that is area total is equal to integration of dA is equal. That is integration of y dx. Integration of y dx. This is the total integration and this is the total area. So my dear friends, can I say, integration helps us to find area under the curve? 110%. So this is the graphical understanding, graphical representation of integration. Is this clear? And what is the graphical representation of differentiation to finding the slope at a point? I'll just write the two statements. Graphical representation of differentiation. Differentiation is to find the slope at a point. That is dy by dx. And when it comes to the graphical representation of integration, is to find area under the curve. That is integration of y dx. This is area under the curve, integration of y dx. I hope every single thing is clear. I have given you the examples in case of differentiation also. I have given you the examples in case of integration also. Okay. Now the question is, how do we integrate? How to integrate? The formulas, okay? See, if you have x raised power n, let's suppose you have got x raised power n. How to integrate it? Let me show you. The integration of x raised power n is simply, if you have to integrate x raised power n, if somebody asks you to say integration of x raised power n, you'll put the integration sign in front of it, then x raised power n, and then you write dx. This is how do you write. Okay, from x1 to x2. So how do we integrate? X raised power plus 1 divided by power minus 1. Example. You have got over here x raised power 3 by 2. We have to find its integration. See, how do we write? Integration of, we say x raised power 3 by 2, and then we say dx. This is how do we write it. Okay. And my dear friends, in this particular case, we can write this is equal to, sir, x raised power n plus 1, power plus 1, x raised power 3 by 2 plus 1 upon power plus 1, 3 divided by 2 plus 1. Power plus 1 upon power plus 1. This would be the integration in. Let's suppose we have got this one. Let's suppose we have got y is equal to x cube. How to find the integration of y is equal to x cube? We say integration of x cube dx, it is equal to, we say x raised power 3 plus 1 upon, we say 3 plus 1. So x raised power 4 by 4. X raised power 4 by 4. Now, if we have a root x, we can also write it x raised power 1 by 2, because value of root is 1 by 2. And if we want to find the integration, we'll write it something like this: x raised power 1 by 2, this is dx. So this will be x raised power 1 by 2 plus 1 upon 1 by 2 plus 1. Okay, then solve it further. Okay. Now see, similarly, I want you guys to tell me the answer of this one. Integration of, see, directly I'll write integration of 1 dx. So this and this will cancel, so it will be x only. Integration of x raised power minus 2, you'll do it on your own. Now, integration of trigonometric functions. Let's suppose you have got sine x, and I am asking you to tell me the integration of sine x. So we say integration of sine x is equal to minus cos x plus c. Plus c we write over here, it is plus c, means plus constant. Write it c. Okay. And then we say if you have to integrate cos x, integration of cos x dx will be sine x plus c. Sine x plus c. Okay. Sine x plus c. Is this clear till over here, guys? Is this clear till over here? Okay. Similarly, if you have integration of sec square of x dx, it is tan x plus c. It is tan x plus. Similarly, if you have cosec square of x, its integration is cot x plus c. Its integration is cot x plus c. Okay. Similarly, if you have integration of e raised power x, it is e raised power x only. You have to remember all of these, guys. And integration of 1 by x is log of x, ln of x. And differentiation of log of x is 1 by x. Okay. Is that clear? Is that clear? Now, let me solve this particular question for you. Let me solve this particular question for you. Integration of sine theta, but the limits are given over here. Let me show you this question, which is based on the limits. Listen to me very carefully. See, if I say in this particular case, sir, we have to integrate this. We know, sir, integration of sine theta. Integration of sine theta. What is the integration of sine theta? That is minus cos theta over here. Sine x, integration for sine x is minus cos x. So we say it would be simply, sir, integration of this sine theta is minus cos of theta. And the limits are from 0 to pi by 2. This is 0 to pi by 2. So what does this limit mean? Limit means, first, you have to put this upper limit, that is pi by 2, in theta. Then you have to put this lower limit 0 in this theta. So we say it is minus cos of. Instead of this theta, you can write this is pi by 2 minus. And then you can write, sir, cos of 0 degree. Then you can write minus cos of, we say, sir, 0. Is this clear? Is this clear? Okay, first, you will have to put the upper limit in theta, that is pi by 2. Then you have to put the lower limit, that is 0. So we can write this is minus cos pi by 2, that is cos 90 is 0 minus 1. So it will be plus 1. So integration of this is, we say, sir, plus 1. Integration of this is, we say, sir, plus 1. Let's suppose we do the integration of this one. Sir, integration of cos theta is sine theta. So we say, sir, it is simply that is sine of theta. And the limits are from 0 to pi. 0 to pi. So we can write it. First, we'll put the upper limit, that is sine of. Instead of theta, we can write pi minus. Then we say, sir, sine of, we say 0. Sine 0. Now this is sine pi, that is sine 180. Sine pi is 180. Sine 180. Sine 180 is 0. Sine 0 is 0. So this will come out to be. Is this clear? Is this clear? Is this clear? Now, addition rule of integration. Addition rule of integration. What does that mean? What does that mean? If you have y is equal to a plus b, it says that first you integrate a, then you integrate b. Simple things. First you integrate a, then you integrate b. It's one and the same thing. Like you have over here. Integration. So you have to integrate this y. You have to integrate, you have to find the integration. Guys, listen to me very carefully. If we find the integration of this one, how can we write? Integration of x square. Integration of x square is x raised power 2 plus 1 divided by, we say, sir, 2 plus 1. Power down, power x raised power n plus 1 upon n plus 1. Then minus integration of 2x. This 2 will be out, and x raised power 1 plus 1 upon 1 plus 1. Because power of this x is 1. So it will be x raised power 1 plus 1 upon 1 plus 1. Then we say plus integration of 4. If we just write integration of 4 dx. So take the 4 out. It is integration of dx. This and this will cancel. So it will be 4x. So it is 4x. So we can write it simply, sir, x cube divided by 3 minus 2x square by 2. 2x square by 2 plus, we say, sir, 4. 2 and 2 will. This is the answer in this case. Next. Can you solve this question? Sir, if we have to find the integration of this one, integrate it. If we have to find the integration of this one, first you will do the integration of sine x. Sir, what is that? Minus cos of x. Then plus. Sir, what is the integration of e raised power x? It is e raised power x only. And what is the integration of 1 by x? We say, sir, it is log of x. We recently saw all of these. Sir, integration of 1 by x is log of x. Integration of e raised power x is e raised power x only. That's what I'm trying to show you over here. First, we are finding the integration of sine x, then e raised power x, and then 1 by x. Okay, let's move on to this one. This is outside inside rule, like the chain rule. See, my dear friends, in this particular case, if we say you have a function y is equal to e raised power 5x, how do you integrate this one? See, what will you do is that we say integration of the outer function, means integration of this whole function, divided by coefficient of c. Let me show you what. In this. See, what is the integration of the outer function? First, we have to integrate this whole function e raised power 5x. Integration of e raised power x is e raised power x only. So we say e raised power 5x only, divided by the coefficient of x. What is the coefficient of x over here? That is 5. So this is 5. This is the answer in this case. This is the integration of this one. I'll put it over here. Okay. Now come in this case. See, First, we'll have to do the integration of this whole term. Integration of, consider this, guys, consider this as x over here. Integration of sine x is what? We say, sir, minus cos x. So we write minus cos of. And instead of x, you have 2x plus 4. So we write 2x plus 4 over here. Then we say divided by cos of 2x plus 4. Then divided by, sir, coefficient of x. What is the coefficient of x over here? That is divided by 2. Come over here. Sir, integration of, first, you will do the integration of cos of x. Sir, that will be sine of 4 minus 3. Sine of 4 minus 3. Then integration of the, sorry, then coefficient of x. What is the coefficient of x over here? Minus 3. Minus. Come over here. Sir, this one. Sir, integration of this is e raised power minus 3x only. Divided by integration of this outer term. Then coefficient of x in this case is minus 3. Okay. Let's come over here. In this case, sir, integration of sine omega t. We say, sir, it will be simply minus cos of omega t. Divided by. Over here, you have to see coefficient of t. Because when it was with respect to x, then you have the coefficient of x. When it is with respect to t, then you have to write the coefficient of t. So divided by, we say omega. Simply in this case, cos of x, when it comes to the cos of x, we say, sir, integration of cos of kx, it is, sir, sine of kx. Because integration of cos is sine and divided by coefficient of x. What is the coefficient of x over here? That is k. Okay, write plus c, always. Whenever you have without limits, you write plus c. Thank you so much, guys. Thank you so much, people. This was all about it. We are done with this particular session. I want you guys to comment down below. Okay. How was the session? Okay. Each and every single thing you guys will let me know. If the session was good, you guys are supposed to comment down below when I end the live stream. Not right now, when I end the live stream. Okay. I hope, yes, vectors will take the another session for that. Okay. Ray optics also I'll teach. Don't worry about that. Chill scenes. So I hope this is clear to each and everyone. And make sure you hit the like button before you leave. Okay. So this was all about it. Take care and bye-bye. Thank you so much. Make sure you comment once I end the live stream. How was the session? Each and every single thing. And I hope I was not fast today. I hope I cleared every single concept. So thank you so much. Take care and bye-bye. Thank you.